Hi. I have no idea whether or not this would be of any use to you, but it's something which I've been thinking about for the last few weeks. That might help to aid the process. I've never actually seen a spark underwater, but if there's something going to generate it, this might. This is basically the parts from a car ignition circuit of days gone by before they introduced a lot of electronics. This element here would be the ignition coil. One side of the coil would go to the car's earth system, and the input to the other input to the coil actually goes to what would have been the contact breaker and the condenser or capacitor across that, just to quench any arcing of the contact breaker circuit, and then that would be powered from the car battery originally. And the idea is that as the distributor rotates, this switch opens and closes. Every time it opens, it generates several thousand volts in the ignition coil, and of course that electricity is then sent to the spark gap through the distributor and then to the spark plug. So if we take away the distributor and all those other components and just have a single spark gap, one single ignition coil, and some kind of contact breaker. Now there's no reason why that should have to be a car type contact breaker. That could be a reed switch operated by a magnet on next to a rotating magnet operating the reed switch or something like that, and or just something as simple as perhaps a paper clip and a magnet, anything which is going to make and break contact when a magnet goes past, so that switch can be opened and closed very, very quickly. And every time that switch opens, there's going to be a spark produced there of several thousand volts, which may mean that you could have your contacts much further apart than you have at the moment, which means you won't get the problem of the contacts welding together, because there will be some distance between them. This may take a little bit more current, but it rather depends on how long the switch is closed for. Ideally the switch is closed momentarily, then opened very, very quickly. Obviously if the switch is closed and stays closed for any length of time, then current will flow through the coil, and that's going to be basically a waste of energy. So if you can just close that switch and open it very, very quickly, then all that will happen is you'll just generate large voltage in the coil. So that's the way that would work, and hopefully would alleviate some of the problems that you're having with the system you're using at the moment, trying to get the thing sparking at a low voltage. Okay, hope that's of some help.